Coming up in this Brightline construction update. In this update, I watched crews drop ballast at the new Melbourne crossover. This crossover is located just north of NASA Blvd in Melbourne, Florida. The ballast for the day's work was brought to the site by Florida East Coast Railway train AFW1. The train crew was told to crawl toward and then hold short of the work site to wait until they are needed, which is what they are doing here. On the train this morning were 4 Herzog solar-powered ballast hoppers. The solar panels on the cars power motors which open and close the doors on the bottom of the car which let out ballast. Crews are able to remotely regulate how much ballast is dropped instead of having to manually operate each door individually, which both saves time and is safer for the crews. This is where the train would come to a stop to wait until they are needed. The worksite is just ahead where all the vehicles are parked along the right-of-way. While I was relocating to a new location, the crew was given permission to move south across the newly installed turnouts so they could drop the ballast as they moved back north. Here they are headed back north at about 1 mile per hour dropping ballast. The crews walking alongside are monitoring how much ballast is being dropped in case the doors need to be opened or closed more to change the flow. Only the first 2 cars were being dropped on this pass. The rest would be unloaded later in the day. After the work train had cleared the work site again, 2 pieces of track equipment arrived from the south. The first piece to pass by was a tamper, followed by a ballast regulator. The cart in front of the tamper is used to help ensure the tracks are straight. Through several forms of technology, the machine is able to calculate how straight the track is and to have the machine move the tracks left or right as needed so it is in the correct alignment. The ballast regulator was the first to go to work. Using massive brushes on the front, it spreads out the ballast that had come out in piles so that it is completely surrounding the ties. Next came the tamper. Like the work train, it first went to the south end of the worksite, then slowly worked its way back north. The purpose of the tamper is to firmly pack the ballast under the ties to provide a flat, stable surface to support the track. The process starts by the machine lifting the track slightly. In my previous videos, you may have seen the new track being lower than the existing main line. This lifting is how the tracks get to the correct height. Following lifting the track, vibrating arms push down into the ballast and squeeze together to push the ballast under the ties. The vibrating motion essentially locks the individual rocks together to form a solid base. Once the vibrating arms come back up, the track is lowered and the machine moves forward one tie. This process was repeated for every single tie until the entire track is complete. Thanks for watching. Be sure to hit the like button and subscribe. Also check out my social media pages.